In this video, I'm going to demonstrate how to achieve the answers for 1 through 5 from various equations to try these problems. Let's start with number 1. So for problem number 1, I'm going to start by subtracting 5 to the opposite side. Square root of the quantity 2x plus 1 equals positive 3. Then I'm going to square both the left and the right, leaving me 2x plus 1 on the left, and 3 squared is 9 on the right. I'm going to subtract 1 from both sides, and I'm going to divide by 2. I feel confident the answer is 4, but I need to go back and check. So using my calculator, I'm going to come back up here, taking the square root of 2 times 4 plus 1, going outside plus 5. This must equal 8. It does. I just checked my work. Let's try it. Problem number 2. Problem number 2. In problem number 2, I'm going to start by moving the x over to the left-hand side, and I'll move the 4 also, over to the right-hand side. So on the left, I'm left with the square root of 2x plus 3, and now I'm going to combine like terms to achieve 2x minus 3. Okay, once I've done that, I can go ahead and we're going to square both the left and the right. On the left, I'm left with 2x plus 3. And this means take this base and we're going to multiply it by itself twice. Now I'm going to quickly FOIL the right hand side. 4x squared minus 6x plus 9. I'm going to move everything over to the right, so subtracting 3, subtracting 2x, and I'm left with 0 on the left. Now on the right, when I combine like terms, I have 4x squared plus 14x plus 6. I notice that each of these is even, so let's divide by 2. 2x squared minus 7x plus 3. Is there a way that I can solve this trinomial? I'm going to try factoring. You can always try factoring here or the quadratic formula as well. 2 times 3 is 6. What two numbers multiplied to equal positive 6 and combined to give you a negative 7? Negative 1 and negative 6. So x minus 1 and x minus 6. Now what a lot of students forget is this leading coefficient. When it's anything other than positive 1 must go down below. Can we simplify this? I can't simplify 1/2, but I can simplify 6 divided by 2. Okay, there's no variable up front, so I'm just looking here at the inside. I'm asking myself, what's opposite of negative 1/2? That would be positive 1/2 and positive 3. I feel confident in my math, but that doesn't mean this problem is correct. So I'm going to come back up to the very beginning, and just so we can see, I'm now going to test 1/2 and 3 to see if this works. Okay, here we go. We have the square root of 2 times the quantity 1/2. Subtract 3. I need to use the arrow to go outside of the radical, plus as I plug in any value, I'm always going to put it in parentheses. So on the left hand side, I achieve a value. I must have plugged in something wrong. Let's try again. Oh, you know what's going to happen here? I see what's happening. The reason I received, let's try this one more time. That looks good. Plus 1/2 minus 4. Okay, there we go. So I get a negative 1/2 on the left. When I plug in 1/2 on the right, I must also get a negative 1/2 to have the two sides balanced. So 3 times 1/2 minus 7. I did not receive a negative 1/2. The left side does not equal the right side. What does that mean? This is an extraneous solution. I'm now going to try 3. So sorry. I have the square root of 2 times 3 plus 3. Move outside of the radical. Plus 3, subtract 4. I get 2. I'm going to plug in 3. 3 times 3, subtract 7. I get 2. The left side equals the right side. I feel confident this is my only answer to this question. So I'm looking right now at problem number 3. I'm going to start by moving these to the opposite side. Opposite of positive 2x is a negative 2x. Opposite of positive 3 is negative 3. 2 times the quantity, 2 times the square root of 7, subtract 3x is equal to negative 1x and positive 5. Now I'm going to divide by 2. We have the square root of 7 minus 3x equals, now don't take time to try to separate this. Just leave it as is. So we have a numerator and a denominator. I now want to remove the square root, so I'm going to square the left and the right. On the left, I'm left with 7 subtract 3x. Now, just as a quick reminder, if I said 3 squared, you know that's the same as 3 times 3. So when I square this amount, it means I'm going to take the numerator times itself twice. I'm going to take the denominator times itself twice. Just like if this was a 3, I would take it times itself 3 times, and I'd take this times itself 3 times. Remember, we can write 1 on the bottom of any value, and it doesn't change the value. Okay, so on the bottom I have 4. Now on top, I'm going to quickly FOIL this. Negative 1 times negative 1 is 1. Negative 1 times 5. 5 times negative 1. 5 times 5. Okay, then I'm going to combine like terms, and I have 1x squared minus 10x plus 25. And now I'm going to cross multiply. So it doesn't matter which way we go first. I could go here. So I'm going to take 4 times this quantity, and I'm going to take 1 times this quantity. Distributing the 4, I have 28 minus 12x. Now distributing the 1 doesn't change anything. In this case, I think it's going to be easier for us to move the 2 terms on the left over to the right. Okay, 1x squared plus 2x minus 3. We could solve using the quadratic formula or create a square, or I think this is factorable. What multiplies equal negative 3 and combines to give us 2. Okay, that's going to be a positive 3 and a negative 1. So x plus 3 and x minus 1. Now, if this was any value other than positive 1, remember we do have to put it on the bottom. Putting a positive 1 is not going to change this value. It still just reduces down to 3 and negative 1. So what's opposite would be negative 3, and opposite would be positive 1. That doesn't mean that these answers will work. So if I come up here, I now need to test negative 3 and positive 1. So I'm grabbing my calculator, and I'm starting here. We have 2 times the square root of 7, subtract 3, times negative 3, go outside the square root, plus 2 times negative 3 plus 3. On the left, I have 5. On the right, I also have 5. That means this value works. Now let's test 1. 2 times the square root of 7, subtract 3, times 1, plus 2 times 1 plus 3. On the left, when I substitute 1, I get it in value of 9. When I substitute 1 on the right, 1 plus 8, we can see is also 9. The left side equals the right side. That means it works. Looking at question number 4, I'm going to start by squaring both sides. Now, nice on the left, this is going to cancel, and I'm left with 5 subtract x. We're going to take this base and write it twice. On the right, I'm going to FOIL front, outside. 3 times negative 1 is negative 3. Negative 1 times 3 is negative 3. And now just a negative times a negative is a positive. And as a quick reminder, square root of 3 times the square root of 3 is just 3. Just like the square root of x times the square root of x is just x. So square root of x times the square root of x is simply x. Okay, let's combine like terms. Let's move the 9 over to the left. Let's move the x over to the left. And now I have negative 3 and negative 3 is negative 6. I can combine them because they have the same, they're like terms. And over here I have negative 4 minus 2x. I'm going to divide by negative 6. I have the square root of x equals, I can leave it like this if that's what I choose to. That's okay too. So if I don't want to reduce right now, I could leave it just like this. Okay, next up, I'm going to square the right. That means I must square the left. What does squaring the left look like? It means I'm going to write this twice, and I'm going to write this twice. Okay, let's FOIL the numerator. Negative 4 times negative 4. Then I have the inside, the outside, and negative 2 times negative 2 is 4x squared. Negative 6 times negative 6 is 36. And at this point, I'm going to go ahead and cross multiply. Well, actually, first I think I'll combine like terms in the middle. So 16 plus 16x plus 4x squared. Okay, here we go. When I take 1 times this quantity, I'm just left with that quantity, and I'm going to put it right now in standard form. Not necessary, makes it a little bit prettier. And then I'm going to take 36 times x. Now let's move everything back over to the left-hand side, leaving me 0 on the right. Positive 16 minus 36 is a negative 20. And I now have a trinomial, a quadratic equation I could solve using completing the square, quadratic formula, or maybe it's factorable. Now what I recognize is that all of these are I can factor out a 4 of all. So I'm going to do that right now. 4 times 1, divide by 4, and divide by 4. This seems so much easier to factor. So 1 times 4 is 4. What two values multiplied to equal 4 combined to give us a negative 5? Negative 4, negative 1. So x minus 4 and x minus 1 equals 0. The leading coefficient is 1, so I can put 1 on the bottom. It doesn't reduce it. If there's anything other than 1, we'd have to. We don't have to worry. The 4 out front doesn't have a variable, so there's nothing here. What's opposite is positive 4 and positive 1. That's what I believe answers that, 4 and 1. But now I must test them. Let's start with 1. We have the square root. Put it off the side here. You can see the square root of 5 subtract 1. And we can see it equals 2. And then 3 subtract the square root of 1. Okay, this works. Now let's try 4. We have the square root of 5 subtract 4 on the left, and then 3 subtract the square root of 4 on the right. Okay, so we can see in both cases the left side equals the right side. It means we do have 2 solutions for number 4. Let's look at 5. Let's take a look right now at how do we accomplish solving this. I'm going to add the square root of x plus 1 to the x minus 1 to the opposite side. And I'm left with the square root of 2x minus 1 equals 1 plus the square root of x minus 1. Then I'm going to square both sides. I'm left with 2x minus 1 on the left. I'm going to write this quantity twice. So 1 plus the square root of x minus 1 and 1 plus the square root of x minus 1. Foiling the right-hand side, front, outside, inside. And remember, when you take the square root of x minus 1 times itself, square root of x minus 1, you're left with just x minus 1. Now, positive 1 and negative 1 cancel out, and let's move this x to the opposite side. I have 2 groups of the same thing, and then let's divide by 2. So x minus 1 divided by 2 equals the square root of x minus 1. I'm going to square both sides. And what does that mean? Well, on the right-hand side, I'm left with x minus 1. Now, on the left-hand side, I'm going to write this twice. Now, I'm going to move that down just a little further. So let's FOIL the top. Front, outside, it's supposed to be negative, inside, last. Front, outside, inside, last, all over 4. When I combine like terms, I have x squared minus 2x plus 1 over 4. Remember, you can put 1 on the bottom of everything. And now I'm going to cross multiply. 1 times itself is just x squared minus 2x plus 1. On the right, I have 4 times x minus 1. 4x minus 4. Let's move everything over to the left-hand side. And I'm left with 0 on the right. On the left, I have x squared minus 6x plus 5. So I'm going to solve by factoring if possible. Negative 1 and negative 5. So x minus 1 and x minus 5. If this was anything other than a 1, it would make a difference if I didn't drop it down below a positive 1. So what will be opposite will be positive 1 and positive 5. Now, that doesn't mean those are right. So I'm going to come back up here, and I want to check positive 1 and positive 5. Let's check it right now. x equals 1 and x equals 5. I have to verify. We have the square root of 2 times. Let's try 1 first. 2 times 1 minus 1. Move out. Subtract the square root of 1. Subtract 1. And let's see, does that equal 1? It does. That means this works. Let's now try 5. Square root of 2 times 5. Subtract 1. Subtract the square root of, again, 5. Subtract 1. Does it equal 1? It does. They both work.